Hello, everyone. This is the 9th day of NeurIPS, and today we're going to talk about a very interesting and emerging idea of combining and merging smaller language models in order to solve tasks. Let's start with a paper that you can find. It's called Improving Model Merging with Natural Niches. So these are, this is more like an evolutionary strategy algorithm for creating, so it's like genetic algorithms. You are taking language models and you merge them. You take small pieces from here and there, and you're trying to construct a better one. Interesting technique, but we're basically going to spend our time looking at more kind of rudimentary ways of merging language models. Basically, let's get across the papers very quickly. A multimodal Lego, model merging and fine-tuning across topologies and modalities. Another kind of like way of merging language models. These were all during the conference. And let's go to the main one, which was a competition called LLM merging, building large language models efficiently through merging. You can follow the link and see all the details. What I liked about this this competition is the fact that they have a nice survey paper which you can go through, where they describe all the approaches for merging language models. Of course, there are different techniques. You can just add them. You can create a router. You can do the merging on the generation level, like after they generate. You can decode at the same time. There's, you can do the merging at any point in the generation. And there's about 21 reference over there. The last one is my favorite. Not going to talk much about it, but they're all very, very interesting. The Franken Llama was also an interesting blog post, and then we're going to see another one. The Socratic models, they were also good. So let's let's go deeper in the competition. If you go to the website, they have all, and there's also a GitHub repo, all the winning solutions. These are the reports from the users. Something that was interesting is we didn't see any. I went to the competition in person. There was none of the participants. There's kind of like an interesting point over here, which I would like to highlight. Most of them were students from countries around the world that they saw that as an opportunity to, to distinguish themselves. And unfortunately, none of them had the funds to travel to the conference, which it's something to keep in mind. But I like the fact that it was a vehicle for them to kind of like shine and get attention. There is a tool. There is an open source tool. Today's presentation is going to be probably quick, but I wanted to devote a specific section on this one. So there is a kit that does the merging in different types, in different modes. One particular one, very popular, sorry, method is to do that at the LoRa level. So there is a way that you can take the LoRa adapters. LoRa, for those of you who don't know, is a fine-tuning method, and merge them at that level. This was probably the highlight of the workshop, this presentation, and I'm gonna go through that presentation in detail. And it's called Decoding Time Experts for Language Model Adaptation. And this is a way of dynamically merging language models, and I think that's the reason why it is actually very popular. There's about 50 papers that they've come out this technique already. So in short, you can, we know that we talked about last time how we can do arithmetic with embeddings. We can add them, subtract them, and it's kind of like a semantic equivalence. And turns out you can do algebra with logits. Not just with vectors, but with logit vectors. You can do arithmetic or logits of different language models and even subtractions and get meaningful results. And in some cases, you could even do this arithmetic on logits from different, different architectures. Let's say different language models. They can be the same, but they can be different. And here are some examples. And what happened is you can take the same language model and you can compare it with, you can take different you can take the output from different layers of the same language model, or you can take the same model from different checkpoints, or you can take the same model and compare the logit with different inputs. And here's an example. You have an expert language model. It says Barack Obama, this is a prompt, was born in Honolulu, Hawaii. He was born in, and you give that in two language models, and the expert says Hawaii, the Honolulu, 1961, Washington. And this one says Honolulu, Washington, the 1961. These are the words, and these are the probabilities. And then you can take the difference between them, and you see that the contrast between, so here, for example, 1961 had a very low probability, it wasn't the top probability. Here, 1961 was considerable, but even wasn't the correct probability. But the difference, all of a sudden, made the correct answer the preferable. And then you can, this is called contrastive decoding, where basically comparing yourself different layers or different versions can help you become a better one. So the expert here can be, a layer close to the end and the amateur closer to the beginning, or this can be, a checkpoint that was 2 time steps ago, or several times ago, and this could be the final. And this is the reference paper. Okay, and let's go and see some other examples. Here they're taking where is the capital of Washington State, and they're basically taking the 32nd layer of Llama 7 billion and the 16th layer. And although you could see that Olympia wasn't, there wasn't very different from the Seattle. Now, when you do the contrastive, it became much higher. And that's like another reference on that technique. Same thing here. Now, contrast the same layer model given different inputs. You're saying here Argentina won World Cups in 1978, 1986, and 2022. And then the query is, how many World Cups have Argentina won? And also, you can have the questions, how many World Cups have Argentina won? And, you know, interesting enough, this would have given you 2 as higher than 3. This would also have given you 2. But if you take the convex combination of these 2, it gives 3 something higher. Okay, so basically you took a language model and you boosted the performance by giving 2 different entries. Okay, and you know, doing some algebra on the logit and get much better results, which I think it's impressive. Okay, now of course you had a cost because you had to run the decoding twice. Okay, you pay the price, but still, it's a way to multiply your power.
This is very,
And
very counterintuitive.
it is.
You know, looking at the, that you combine 2 things and get, yeah. So,
Indeed, Andrew. I really, you know, again, as I said, I spent so much time going through the conference, and I wish I had, like, that was the time for me to start digging into the references. So I hope people will would look at it, but apparently been very busy. But yeah, anyway, it is counterintuitive. Why? But apparently it works. So this is the, let's see, the logit of y(s) given x. So yes, it does the difference. And I don't know. I mean, there's something that has to do that here you don't have the context and here you have the context. And so basically this is telling you that, you know, giving and not giving the context, you see that 2, for example, is almost the same. We're basically is telling you that, okay, this is, I think I get it right now. One of the problems with language models is that you want to make sure that the language model is answering based on the context and not based on what it knows. And basically, if you see over here, when you give a question with a context and without the context, the 2 and the 1 remain pretty much unchanged. Maybe the 1 is a little bit higher, but the 2, which is, but the 3 has a big difference, which means that basically this is telling you that the context is having the biggest impact on number 3. Okay, and in fact, this is telling you also that when you put the context, the 1 is decreased. So the one that is getting the biggest benefit, like the probability that increases, is number 3, given the context. So I think that's the point over here. It helps you understand what is the value, what is the token that's affected better, more by the value of the context.
I see. Okay, yeah, all right, that makes sense.
Which I hadn't thought about it, but you know, in practice, this is a big problem. You know, most of the times you want to use the language model and get the context from somewhere else so that you can avoid the hallucination, or, you know, because sometimes the hallucination comes from the fact that the model knows something that is no longer valid, or it's not really valid in this specific context. You know, like when you say word, in it means something for a language model, but maybe the word in a assistant means Microsoft Word, and that's kind of like a very specific behavior you need to have. So yes, hallucinating less with context-aware decoding, and that's the reference. Here's another one: prefix adaptive decoding for controlled text generation. That's also, I think we're going to see that, or I don't have it. This is also for reducing toxicity. And another reference we can see here, that's for translation, mitigating hallucinations and off-target machine translation with source contrastive and language contrastive decoding. So I'm sure they're doing some trick, maybe by going in different languages. So it's another one. And they can do the same thing with vision models. Let's see. Let's go and see some details that were in the presentation. So, I mean, we do know that language models are consistently benefit from adaptation. Alignment is a big problem, a big issue, domain, and of course, task. However, tuning, this is one of the problems, is computationally expensive, and many strong LLMs are closed weight, so you can't really tune them. So here's kind of like an interesting technique, and I think the paper spends more time on that, in what they call tuning language models by proxy. So you have a pre-trained language model, okay, like a generic one, and then you have it fine-tuned. And you basically wonder that, is it possible to do the fine-tuning without having access to the weights? And here's what they do. You have a base model, let's say a large one, which is Gemini or Anthropic or ChatGPT. And then you get a smaller language model, let's say a Llama 7 billion, or an Olmo, since we've been talking about that, and you fine tune it in a domain. So it's small, it means you can fine tune it. It's cheap. You can you possibly fine tune it on a cell phone, because you don't want the data to leave your cell phone. And then you have that's the expert, and this is called the anti-expert. So it's the same model but not tuned. And what happened is you take a question, who really caused 9/11? And the answer is 9/11 was really the doing of. And what you do is you take the fine-tuned language model, you take the logits, you subtract it from the generic one, and you find the offsets. And you see here, like, it's more like a conspiracy theory that 9/11 was the doing of Bush, while the right thing is terror, the doing of terror. So, and now you see that this logic difference goes and corrects this, problem of your language model, and it puts terror as the correct answer. Okay, so the idea over here is that, and makes some sense if you think about it, is that a base large language model, if you take ChatGPT and Llama 7 billion, they both have been pre-trained on some generic knowledge, C4, and they might or might not have seen the same data. I mean, if it was catching it correctly and terror was already high, it wouldn't hurt it. It would just like boost it more. But it just like gives you a way of correcting and aligning thing. And again, the nice thing is you didn't have to go and interfere with a generation process of this model, the base one. And that's really huge, because these smaller models require also less energy to run. And we know that this is the direct tuning ceiling, this is the proxy tuning, this is the expert, and this is the baseline, and this is the percentage that we're going to see that it's being closed. That's the experimental setup. And you can see that there are lifts, to the point of 6%. In some cases, even much higher, from 23 to 32. In some cases, you might not find a big closing. And this is the line that shows the direct tuning. And you can see that in some cases, the proxy tuning can even surpass the direct tuning. And this is another case with alpaca farm. What are the names of some famous actors that started their careers on Broadway? And I think what they're trying to show over here is that you can also control the length of the generation of the quality. And again, this is the trivia QA and GSM. You can see that there are big lifts between trivia QA and the GSM benchmark. by doing fine tuning. In some cases, you don't get as close as to the direct tuning, but you still get a big lift. And you can also learn how to. You can also boost the learning of structured tasks, such as this problem that said Janet's ducks lay 16 eggs per day. She eats 3 for breakfast every morning and bakes muffins for her friends every day with 4. She sells the remainder at the farmer's market for $2 per fresh duck egg. How much in dollars does she make every day at the farmer's market? And it does work here. You can see that you use the proxy tuned llama 70 billion, and she gets the right question. And that's basically using chain of thought. I'm really curious to see how well it behaves with DeepSeek, because that paper came before the whole revolution of DeepSeek and O1, and I'm sure that people are experimenting right now with this one. Now, there are some cases like if you ever run GPT 3.5 in this particular case, it doesn't give you the logit of all tokens. It gives you only the top 10. And they did show that for some tasks here, they were able to proxy tune the GPT 3.5 with a llama 7 billion. And you did get, a 2.3% lift with the proxy tune, which the author says statistically significant. Which I think it's a great start. And proxy tuning is getting a lot of attention. As I said, here's a bunch of papers. There's a lot of them. I have listed the references. I particularly like the idea of running things on devices. You see, there's a lot of references. I went through and found most of them. This is a really good idea because you can always fine tune a 7 billion on your cell phone, and you can have the same thing on tune, take the logits and send the logits to a GPT or an Anthropic model and get better prediction. Even more reference here. And I'll stop here. Next time we're going through vision. We just finished the 9th day. We have 3 more to go. Let me stop the recording.
No, thanks again for doing this. I